2, lesson 3-1, example 4, sketch the graph from a verbal description. So in this example, we're going to sketch a polynomial in a graph using some words. So let's look at this example. How can you sketch a graph of a polynomial function f from a verbal description? So let's look at these descriptions here. F of x is positive on the intervals from negative infinity to negative 4 and negative 1 to 4. Okay, so it's gonna be positive from negative 4 when x is negative 4 until negative infinity. So it's starting here, it's just going to be positive, right? And then from negative 1 to 4, it's going to be positive as well. So maybe it should come down at some point. It's going to go up and then it's going to come down, right? Doesn't say increasing, decreasing, it just says positive. So this is when your y values are positive because f of x is y, and that is positive. Okay, f of x is negative under intervals negative 4 to 1, so it's going to also have a curve here. And then from 4 to infinity, positive infinity, so it's going to be negative and negative. So you see two turning points probably, and you see the end behaviors like this, which is probably gonna be odd degree functions, right? With a leading coefficient of a negative coefficient. So first of all, that's the clue. And then we want to find where it's decreasing, where it's increasing exactly. So it's decreasing from the intervals from negative infinity to negative 2.67. So the turning point right here is at exactly negative 2.67. Okay, and then from 2 to positive infinity. So this is another turning point where it's at exactly 2. So we know where the turning points are at. Okay, so at here here. When x is equal to negative 2.67 and when x is equal to exactly 2, it's going to be your turning point, and then the graph shifts. Okay, and we know where the graph is positive and negative as well. So even though we don't know the exact values for y, we can still draw a pretty accurate graph using these verbal descriptions. Okay, so first we can identify or estimate the x-intercepts. We know the x-intercepts by your intervals, because x-intercepts are when y is equal to 0 or when your graph intersects your x-axis. That means your graph will be changing from positive to negative or negative to positive. So those are going to be your x-intercepts. We have 3 major x-intercepts, right? At negative 4, negative 1, and positive 4. And then we're going to identify or estimate turning points at exactly negative 2.67 and 2, which we did. And then we're going to evaluate end behavior, which we already did. And then we're going to sketch the approximate graph. You can label these points so that it's you should label these points so that it's accurate. We don't know how low our y values are going to be, so our y values are not labeled, and that's okay. We just know that your x-intercepts are at negative 4, negative 1, and 4, and your turning points are going to be at exactly negative 2.67 and at exactly 2. Okay, so as long as those facts are correct, your graph is correct. All right, let's look at try number 4. See if you can do this by yourself. Use the information below to sketch a graph of the polynomial function y equals f of x. So look at your information here, verbal descriptions about where your graph is positive or negative or increasing or decreasing. Okay, so pause the video and see if you can do it by yourself and come back when you're ready for answers. All right, are you ready? Let's look at the first verbal expression. F of x is positive on the intervals -2 to -1 and 1 to 2. So you already know there are going to be x-intercepts, right? It's positive from -2 to -1. So then the graph has to come back from 2 to -1 because it's going to be from -1 to 1, right? And then, so these are your x-intercepts, -2, -1, and 1. And then it's positive again from 1 to 2. And then from 2 to infinity is negative. And then from -infinity to -2, it's negative as well. So we already have identified the x-intercepts. X-intercepts are, there are 4 x-intercepts here, right? -2, -1, 1, and 2. So those are the things that we can know when they tell us about your graph being positive or negative in the intervals. And now we want to see where it's increasing or decreasing so that we know where the turning points are at, right? It's increasing from -infinity, yeah, we knew that, to -1.5. So it's going up from -infinity until -1.5. So this turning point is -1.5 comma a y. We don't know. And then another turning point will be, let's see, wait, it's also increasing from 0. Okay, so this is going to be another turning point, 0, right? 0 comma y. We don't know what y is, but this is another turning point. And then until 1.5. So then it starts decreasing from 1.5. So another turning point, 1.5 comma y. And so you can look at the last one. It's not as important now that we have figured out all the information, but we can just double check that that our information is correct. It's decreasing from -1.5 to 0. Yep. And it's also decreasing from positive 1.5 to positive infinity. Yep. So yeah, that would be an accurate graph. You could draw the x and y axes, and that should be correct. All right. So that was try number 4. You didn't have to label the grid lines for y, but if you did, that's fine. It's not technically wrong if you go way too high or way too low. That's fine. Like, it's not even part of our description. So as long as your graph is positive between the right intervals and negative between the right intervals, and it's increasing, decreasing between the right intervals, your graph should be fine. Okay, so that was example 4, and try number 4 using verbal description to sketch the graph of a polynomial function. We're going to look at our last example, example 5, using applications in real-world problems in the next video.